Welcome to Notes 3.5. In today's lesson, we are going to be studying composition of functions and systems of equations that have an absolute value equation and a linear equation. To get us started, let's explain how the composition of functions works. So if you remember, g of f of x is the same thing as g of f of x. And in this case, what it means is we would take f of x and we would take the equation that represents f of x and substitute it into g anywhere we see an x. Let's look at our first example. It says given g of x equals 2 times the absolute value of x plus 3 minus 4 and f of x equals x plus 2. They want us to find g of f of x. Well, the first thing I'm going to look at is, okay, well, what is f of x equivalent to? And f of x is equivalent to x plus 2. So what that means is anywhere I see an x in g of x, I'm going to replace it with an x plus 2. Let's see what that looks like. So I left a blank open spot for my x. Well, in place of x, I'm going to substitute in x plus 2. Then I clean up the inside. Well, x plus 2 plus 3 is equivalent to x plus 5. So therefore, my final answer is g of f of x equals 2 times the absolute value of x plus 5 minus 4. Okay, now that we know the composition function g of f of x is equal to 2 times the absolute value of x plus 5 minus 4, what if I wanted to find g of f of negative 12? Well, if you remember, this notation is the same as g of f of negative 12. Well, there's two methods to do that. The first method is if I know the composition function, which I do. So what I would do is I would take the x in the composition function and replace it with negative 12. From here on out, it's just a simplification. Absolute value of negative 12 plus 5 is the absolute value of negative 7. But the absolute value of negative 7 is positive 7. 2 times 7 is 14. 14 minus 4 is 10. So I could say that g of f of negative 12 is equal to 10. Done. But let's suppose for a moment, what if I did not know the composition function? What if I just had g of x and f of x? Well, the first thing I would start off by doing is I would figure out what f of negative 12 is. So that's negative 12 plus 2. Well, negative 12 plus 2 is negative 10. So I would then replace f of negative 12 with negative 10. So that would be like me saying g of negative 10, right? So that would be, again, like me saying g of negative 10. So that means I would then take negative 10 and replace it in the x of g of x. So that's how I get 2 times the absolute value of negative 10 plus 3, which is negative 7. That's starting to look like what we had on the left side. Don't think that's a coincidence. So the absolute value of negative 7 is positive 7. Well, 2 times 7 is 14 minus 4 is 10. So you can arrive at the answer using either method. But either way, we know that g of f of negative 12 is 10. Okay, let's try some practice on your own. What I want you to do is I want you to hit pause. I want you to try these two problems, and then when you're done, hit play, and I'll give you the answers. Okay, let's see how you did. I had that g of f of x is equal to 3 times the absolute value of 2x plus 5 minus 2. And then over here, I found out that f of g of 4 is equal to negative 17. Okay, let's move on and let's look at solving systems involving absolute value. Well, I have y equals 4x plus 6 and y equals 2 times the absolute value of x plus 5 minus 6. Now, I notice that they are both equal to y. So thanks to the transitive property, if A equals B and B equals C, then A equals C. So that means if they're both equal to y, they're equal to each other. So my first concern here is that I need to isolate the absolute value portion of this equation. So the first thing I'm going to do is I'm going to add 6 to both sides. That gives me 2 times the absolute value of x plus 5 equals 4x plus 12. I then am going to divide each term by 2. When I do that, I have absolute value of x plus 5 equals 2x plus 6. So if we remember from 3.2, that means that the inside can be 2x plus 6, or it could be the opposite of 2x plus 6. So that's what I'm going to do. I'm going to take and set the inside equal to positive 2x plus 6, and then the opposite of that. So what I did is I went ahead and distributed my negative to be negative 2x minus 6. Now I have to solve each one for x. Well, the first one's not too bad. I'm going to subtract x from both sides, and then I'm going to subtract 6 from both sides. So that gives me x equals negative 1. Over here, I'm going to add 2x to both sides to cancel this guy out. So that gets me 3x equals negative 11. I then divide by 3, and I get negative 11 over 3. Now, I have to check my work. I have to make sure that it makes sense and works in the absolute value equation. So what I'm going to do is I'm going to plug them back in to this absolute value of x plus 5 equals 2x plus 6. Now, it doesn't matter which of the 3 equations you use. You could plug it in here, you could plug it in here, or you could plug it in here. Again, it really doesn't matter as long as you check to make sure that it works in one version of the equation. So I find out that, negative 11 over 3 doesn't work. So the only one that works is negative 1. But wait, you're not done. The solution to a system of equations is a coordinate point. It's a point of intersection. Well, I have an x, but I need the y. So let's move on to the next slide. And let's figure out how do we get y. So I know that x is negative 1. That's the only one that worked. So I have to plug it back into one of the equations and figure out what y is. Now, I don't know about you, but the linear equation is simpler than the absolute value. So I plug in negative 1, and that gives me positive 2, because 4 times negative 1 is negative 4. Negative 4 plus 6 is 2. So that gives me the coordinate point negative 1, 2. But you also want to make sure that it works in both equations, because remember that intersection point has to work in both equations or else it's not the intersection point. So I'm going to check. Well, we know it already works in the top one because that's how we got y. But let's plug it into the absolute value. So that would be 2 equals 2 times the absolute value of negative 1 plus 5 minus 6. So that's 2 times the absolute value of 4 minus 6. Well, the absolute value of 4 is 4. So that would be 8 minus 6. It does. Yay, it works. So that is my solution. All right. Now, let's think about this question. Given the following systems of equations and your knowledge about graphing transformations, explain how you can deduce without solving that the following system has no solution, which means it will not intersect. So think about it, hit pause, and then come back and see if you were right. Okay, let's look and see how you did. Well, we know that 2x minus 7 is going to be a line, right? It's going to be a positive slope line that starts at negative 7. And then we know the absolute value will be negative 4, positive 3, so somewhere about here. But using what we know about the slopes of the sides, the slope of each side is going to be plus or minus a times b. So that means I'm going to go up to over 1, up to over 1, and then here up to over 1, up to over 1. So when you graph it, these two pieces of the graph are going to be parallel. Therefore, they will never intersect. All right, that's it. That's the end of the lesson. You will now go on and complete worksheet 2.5, which is also a review for your quiz that you will have next class period. All right, have a good one. Stay safe, social distance, wash those hands, wear your masks, and have a great one. Bye, everybody.